Good afternoon, or good morning to the folks attending our event to the west of us, and thank you for joining us for another Parabellyx roundtable discussion. Our subject today is one that should be important to a broad range of organizations as we focus on application development or winning the application security race, and we discuss how software development teams can ace cybersecurity. My name is Mike Opzoomer. I am the Director of Sales Operations at Parabellyx, and I'll be your host for the event this afternoon. Our producer and man behind the scenes for this event is Barry Hillier. Thanks you very much, Barry, for helping make this event happen. And alongside me today, we have four seasoned experts providing their unique perspectives in the field of application security. Alexander Poizner, founder, CEO, and co-chief cyber strategist at Parabellyx Corporation. We have Neezam Hanif, a cloud computing specialist with over 20 years of data center experience in storage, virtualization, security, and networking, as well as supporting developers from a build and tooling perspective. Welcome, Neezam. Got Eric Matthews with us, chief technology officer and senior information security engineer and architect at Parabellyx. Finally, we have Greg Drazenovic joining us. Greg is the Vice President of Infrastructure and Security with Canaccord. Greg, good morning, and thank you very much for joining us. Now, I don't think anyone will disagree. There is a silent but not so subtle war going on around us, with the internet being the new battleground. Malicious actors and government-sponsored groups have stepped up the level and severity of attacks, moving away from attacks on individuals and focusing on large organizations, government, public infrastructure, and critical supply chain points, typically with the intent of causing damage, charging ransom, or possibly for political reasons. And whether it was prompted by the pandemic or intensified by it, organizations and their respective security teams now have to look at protecting and monitoring more than just the network perimeter and endpoint devices, instead keeping their eyes on every device, user, and application that touches the internet, on-prem, remote, or even in the cloud. And at the forefront of these vulnerabilities are the applications your employees and customers use. In the past, we put a lot of faith in companies like Microsoft and Google using their massive teams and large wallets to apply due diligence, developing and securing their products and ensuring their clients' safety. But nowadays, we rely on more than just enterprise-level applications to run our business or interact with customers. Businesses rely on multiple smaller applications, custom-built for the services that they need to provide. Business transactions, order management, data collection, and retrieval, etc. And organizations do this without the massive development teams and Microsoft-sized wallets. So with a multitude of open source libraries, tight publishing deadlines, and basic human error, it's not difficult to see why this has become a target of choice for malicious actors. Our focus today is to discuss strategies, trends, and solutions to arm your development teams and reduce the risk to your organization and to your customers. So I'm going to throw the first question out to Eric. Eric, for over 20 years, the primary technical focus of cybersecurity was on infrastructure components. What factors are playing a major role in the shift in attention to application and security and software development security?
I mean, it's a good question. I think what we see today is that the primary point of interaction with data for companies and for organizations across the world has shifted from a client server mindset to using infrastructure, having for example, an FTP server, to really using the apps as the primary customer gateway. We see a shift away from having on-prem services and a shift toward placing data and assets in the cloud, and then exposing those with a simple application, whether it's a web app or a mobile app. That's really been a change, and I think a change in mindset for both IT as well as security in a more specific sense. And that shift has changed the attack surface, has changed the attack point on the network from being concerned about the firewalls and the infrastructure, which still need to exist, but to really focusing on the application code, the application development, and how those applications are deployed and managing data.
About that, Neezam, I'd like to throw it over to you, just to get your perspective on that.
Sure. So what I'm observing is that digital transformation is something that a lot of organizations are facing. And digital transformation is not simply a means of trying to optimize what you're using, but it's a change in the mindset. So IT organizations now are challenged in trying to align themselves with the business and work towards business outcomes and business objectives versus just trying to stand up and do what I call the maintenance marathon. And as a result of this transformation, it's changing the paradigm in terms of the way applications are developed and consumed. And in that, it's exposing new ways of threat actors of being able to penetrate and exfiltrate information from organizations.
I appreciate the insight there. Greg?
So I want to take, advance what Neezam had talked about with business transformation. What I'm seeing in the industry is regulation is having a massive impact. The protection of data, heavy fines. Internally within our organizations, risk department, there's a lot of internal pressure. There's things like you can't get cybersecurity insurance unless you pass certain capabilities. Internal audit is asking a lot of hard questions. We're asked to do risk registers, third-party risk management assessment. The boards are asking a lot of questions. Cybersecurity committees are asking a lot of questions. Cybersecurity has become top-down rather than bottom-up in the last 6 years, what I'm seeing. But not just that, though. IT shops are becoming much more aware and exposed and knowledgeable about cybersecurity breaches. And I'll say that the one thing that I'm seeing is from a bottom-up perspective, the best thing that we ever did is we hired a developer to become a cybersecurity expert. And by doing that, that's really helped us because they can speak the same language. So that's something that I found really useful.
And that makes sense. That's very intuitive. That's not a bad approach. Let's say a company just started building their AppSec and software development security practice. Throw it back over to you, Greg. Greg, what advice would you give them to set them on the right course?
It's all about training, right? When I went to Georgia Tech and I did my master's in computer science, and they would teach us how to perform a buffer overflow attack, break encryption, perform cross-site scripting attacks. Look, if you're going to get adoption from your developers internally, you have to show, don't tell. You have to show them the vulnerabilities, right? But then you also need to educate them, right? There's a lot of really cool frameworks out there. I really like the OWASP, Application Security Verification Standard. They have the Application Security, standard, gives you requirements, helps you, understand what tests, can be used by architects, developers, testers, security professionals, you name it, to help and build and verify and secure your applications.
Alex, Greg says it's all about training. Do you agree?
Well, there are 3 components or ingredients for building a successful application security program. And Greg did mention 2 of those already. Those 3 components are really around empathy, meaning that you need to listen and understand developers. You need to listen and understand the business context of application, user stories, rather than just thinking in context of security controls around the application. Then, yes, you need to have a right security champion, meaning that someone who has software development experience, understands SDLC, has the ability to understand the applications. And the third one is, as Greg said, around training. And with training, everybody thinks training from the perspective of security awareness. And I prefer more of a Kaizen style approach to the training. Understand what kind of security issues or vulnerabilities your application developers are producing. Have that study, and then use a focused training for the team to make sure that they are improving their cybersecurity skills. And those 3 components, empathy, right champion, and focused training and continuous improvement, are 3 things that you need to build a successful practice.
So a security champion at the top of the food chain to kind of make sure that everything is going along properly. Neezam, anything to add to that?
Oh, yes, definitely. So I agree with what Greg and Alex have to say, but I think there's another part of the security framework that needs to be considered. So having lived through a number of different large projects, one of the things that I think is important is that security should be participating in every phase of a project, from conceptualization to architecture to development to implementation to pre-prod testing all the way to production. And the reason being, because I lived through it, is that if security gets onboarded later on in the process of realizing a product process or whatever the case may be, there might be architectural decisions that are made that can't be undone because it might be cost prohibitive, or it may require re-architecture in a major way. So I think as a security group, getting involved early ensures that everything is able to get to the finish line intact without any type of compromise or shortcomings.
So I think we've boiled it down to planning, training, and having the right team to take you through to resolution. So now I read an article a few days back that started with flawed applications are the norm, and it set the tone for what followed. It stated that 76% of applications have at least one security flaw, but unluckily, I guess, only 24% have high security flaws. And to make things more complicated, almost 70% of applications inherit at least one flaw from their open source libraries. And the article went on with a bunch of other frightening statistics, but what it boiled down to was many of these flaws have the potential to cost organizations significant losses of time, resources, and reputation. And many of these flaws could be caught early on. So, Neezam, you've been through this before. What would you say are easy wins when it comes to software development security? What should software development teams start doing right away?
Based on my prior experience, sometimes when components or modules are onboarded that are third-party open source or even commercial, the one thing I like to do is I like to assess the modular component. What I'm trying to identify is, does that component or module do more than a developer wants to do? Because if that's the case, then it becomes a question of, do all the features need to be enabled, and is it possible to disable the features that are not necessary? And if that's the case, then narrow down the scope of features that are available in a module component so that only what's necessary is running. And if there's a configuration file associated with it, make sure that configuration file is locked down to only provide that capability. In addition to all that, you also want to be able to keep visibility on things like configuration files or any other file that contributes to that function of that component or module. Because what you're trying to do is, in one way, limit the damage scope, but secondly, you don't want to provide another avenue of attack that if someone breaks into the server, they get to the configuration file, they change it, they can end up exposing that vulnerability and making use of it to get further down into your network.
All right. Greg, can you add on that?
When I think of developers, I think of them as high school athletes. And when I coached high school athletes, one thing I realized very quickly is if you can't make them better, they won't respect you. And why I bring that up is when you think about developers, if you can't tell them something they don't already know, they're just going to know you. They're not going to work with you. And if you come from an infrastructure background like myself, knocking on the door of the developers for years, you never got anywhere. You really had to speak their language. So you have to tell them things they don't already know. So do things like secret scanning, open source composition, static analysis, data discovery, classification. Always encrypt the data at the beginning, like Neezam kind of talked about. Perform risk registers. One of the biggest challenges that we had in our early adoption is we did static and dynamic scans, but we only pointed them towards select applications. And it wasn't until we had a herd mentality when we actually started to aggregate all the code into a centralized repository, perform those scans, that we could actually start to really materialize the program and really tell those developers things that they didn't already know. And that's how that program started to organically grow. And we got adoption.
Very good. And it sounds like you're going back to the thought that training and making sure that you've got the teams informed and comfortable with what they're doing and acting as a team is fairly critical. Eric, anything that you want to bring into that?
Well, I mean, there's with all security, there's two things you have to look at. You have to look at the tactical. What do we do right now? What can we take as a quick win? And I think really being aware of what vulnerabilities are in an app as it's presently deployed or as it is in its process of being developed is important. So regardless of what happened in the past and whether or not there's been a security approach in the build and architecture of the app, I think it's important to get a good baseline to really be able to present that to the developers or work with the developers to understand that. But then really there's the mantra of shift left in the development space, where we want to move as much as we can early in the development process. So the earlier you can get into the security stance in the development environment, the better it is in the long run, the saving money, saving time. So if we can, in a tactical view, understand what's there right now, and then in the strategic view, to really get in front of those, to build security into the development practice, into the automation, make sure that that's a core piece of both the tooling as well as the mindset and culture of the development teams.
Right. You mentioned shifting left. Alex, is there anything that you want to bring in? When we talk about shifting left, we want to make sure that that we have the appropriate tools and the appropriate resources available. Can you expand on that?
Definitely. So, a few things that you have to think about is, first of all, do you have the right tools to make a decision? And that's all about the lay of the land and staying information, like Neezam said. Do we really understand what's going on with all of the software components? Do we have the understanding of the requirements and the stories around the application? And also the tactical tools around making sure that we can catch what's going on with the code early on, rather than looking at getting it at some point later, such as during penetration testing, or if you have a security quality assurance cycle. So the best thing is not to wait for this stage. The best way is to make sure that you have the right tools for software development that can catch any issues early on, or help you plan security, not just on the infrastructure control side, but also within the application early on.
Great. Thanks. Hey, and folks, as I had mentioned at the top, we do encourage questions. We'd like some interaction. But because we've got your mics muted, we ask that you put your questions in the chat window. You'll find that on the right-hand side of your window. And if you could put your name before the question, just so that we can attribute it to the right person, we'd appreciate that as well. So let's jump forward from there. So Alex, I'm going to come back to you on this. What do you think is the role of internal cybersecurity teams in application development, given that most of the skill sets in the team are still geared towards the infrastructure security? Can a team like that enable better, faster, and of course more secure software delivery?
So that's an excellent question, Mike. First of all, let's talk about the role. Security team usually gravitates towards a position of power. Think about security governance, risk management, prescribing specific controls, doing penetration testing, and prescribing specific fixes. We are used to dictate what we need from other teams. And that's really not how you want to build the relationship with application development teams. And when you're building that relationship, you need two things. You need a guide or a Sherpa, and you also need an enabler. Now, a guide is going to be somebody who will help application development teams in terms of understanding why specific security requirements should be there, why they're put forward, and then helping them to understand how they can execute, but also takes back the feedback from those discussions to security team, because all of those requirements will need to be taken in a context of application, technology, business process, which sometimes would change those requirements. And that feedback, I have seen a lot of times where somebody who is working with application security teams does not necessarily provide this feedback back, or is reluctant to take this feedback and make decisions just because there are certain very strict governance guidelines of what they need to do. So this is something that you'll need to work around. And this is why the teams will need that guide. This guide will also help prioritizing anything that application development teams will need to do from the security perspective, because yes, you will need to prioritize. You absolutely will not be able to deliver everything that you need from the application security fixes right away. And some of the fixes will be more of higher priority versus lower priority, depending on that context that guy will need to understand. The second person is an enabler. And this is somebody that is going to help application security team to get what they need from application team to get what they need from the security team. Because think about it, we in large organizations usually are locked behind various IT forms and requests that they need to fill out. Now, it's not necessarily true that those teams are aware what they need to do from their perspective. So again, you need somebody integrated within the team that can be there to answer the questions, can help them with various requests, can help them navigate in terms of the requirements for those requests, but also who can advise them on things such as technical solution design around even infrastructure security, and getting things done behind the scenes with security team, making sure that all of those requests go through. So those two roles are extremely important. And yes, absolutely, those two roles do not require a lot of software development or even SDLC skills. They really require the integration between the teams, and they really require some dedication. But that's really it.
So the guide and Sherpa and the enabler role. Neezam, if I understand correctly, you have been in both of those roles. So I'm going to throw that question over to you. Given that most of the skill sets in the team are still geared towards infrastructure security, can a team do this? Can it enable better, faster, and more secure software delivery?
For sure. Just because their infrastructure doesn't mean that they have intellectual property in their mind and how the business works. So what I mean by that, if you go back to what I was talking about, in software development teams should have security as part of every part of the phase of a project. The architects understand governance and compliance. They understand the inputs, the outputs, and the behavior of the system. So the governance and compliance can govern the behavior, the inputs and outputs, and identify potential risks at that point in time. And what that does is that as you go through the development cycle from architecture into development and so forth, because you've had that guidance at the top, it flows through as you go through the development process. Now, that being said, there's going to be security champions at every level. You're going to have your developers, you're going to have teams in the pre-prod team, you're going to have individuals across the board or groups of people that will confirm that what was done at the architecture level follows through all the way through to production.
So security champions, guides, Sherpas, enablers, and architects. Greg, throwing this over to you. Do you agree that this is the format? This is the form that provides the highest level of success for an application development team?
Well, I grew up with a very influential role model. It was the cartoon G.I. Joe. And in that cartoon, they talked about knowing is half the battle, right? And I think that's one of the biggest challenges that teams have is knowing what is in front of them. And that's why I talk a lot about the centralization of the code. You know, there's a repeating theme after Neezam and Eric's, comment. So Eric's shift left, Neezam, with, having the developers engaged from day one. And the reason is that there's this natural conflict, right? Applications become rusty over time. And then once you do have that exposure, it's that technical debt that is very, very expensive. And you have this conflict between features and cyber. And it's sometimes hard to go to the business and to get the funding to repair a lot of those types of issues. So I do believe that you do have to get them engaged very, very early on. And it's a different mindset mentality and it's a different culture in order to be successful. Some of the frameworks I like, though, is like the OWASP, security knowledge framework. It's a pretty good framework. That OWASP Juice Shop is great for hands-on tools that help you look for vulnerabilities. But the reality is you have to go back to the GI Joe concept, right? You have to know what you have in your ecosystem. And once you know that, then that's when you can start to get yourself out of the hole. But gotta tell you, it's hard. It's hard financially to go to the business when you've developed the applications and then you want to go back and say, hey, this application's got 2 years left in it. Do we actually spend the time to repair it? By the way, who's going to repair it? Because those developers are focused on money, revenue generation.
Well, hopefully we've started a bit of a trend, and going forward, the development teams that are on this call will start calling their team leads GI Joe. I think that's a great analogy. So I'm going to throw out this next question to everyone. Greg, I'm going to start it off with you. So, folks, Log4j is still fresh on everyone's mind. What are the key takeaways from the entire ordeal that forced a lot of security professionals and application support specialists to work through the entire holiday season? Greg, what would you say the key takeaways are?
Well, I do come from an infrastructure background, so I am going to, go on the infrastructure side and say having a WAF cannot be underestimated. Like you're able to remediate a lot of these threats by having a WAF that can, that has some sort of automation and is able to identify these types of threats. So you can't just completely abandon, infrastructure. It's part of the conversation. But disabling features are not used in libraries. I think the average application contains code from 32 different libraries, but only 14 are active. So making sure that developers know what they're doing. Always patch libraries before a new release. I think 86% of open source libraries do not use the latest versions, right? Meantime remediation is like in the hundreds of days type of thing.
Seems like a very, very simple task to start at the beginning of a process that a lot of companies are skipping and slipping on. Alex, same question over to you. What are the takeaways from the Log4j ordeal?
Thanks, Mike. So it's kind of interesting thing that every time we have such ordeal, whether with libc, OpenSSL, or any Log4j, we are asking this question and saying, well, what have we learned? Now, for me, the biggest takeaways are that we, as an organization, as software development team, as security team, need to have a complete software bill of materials. We need to understand what libraries we have. We need to understand not just about the software libraries, but the entire ecosystem, because it may not be as part of your application, but it may be a part of your container build or anything else that use a third party in a cloud. So you need to understand this. And we've learned that we cannot really rely on vulnerability scanners to create that software bill of materials, because in the beginning, as the vulnerability scanning companies struggled with creating the right patterns and the right tests, we will be partially left in the dark. And that's what has happened with a lot of vulnerability scanners in the beginning. So having the bill of material built by a tool that is separate from the vulnerability scanner is something that you really want to consider at this point of time.
So, Neezam, Log4j hit a lot of folks out of the blue. It came as a real surprise. We've seen some companies that have reacted well, and some that still haven't taken action as yet. And there's probably another Log4j event that's going to happen down the road. So, I'm throwing the question over to you. Any key takeaways or any advice that you can give to these companies to make sure that down the road they don't have to get their employees to come in over Christmas again?
So I'll start off by saying cybersecurity is a team sport. There are no spectators. Everybody's a participant, active participant. And what I mean by that is you'll have on the infrastructure side, your server virtualization administrators, your network administrators, you have your cybersecurity group, and then you have your developers. And what I observed in Log4j is that not all the tools in the toolkits across all the different organizations were leveraged. Greg had brought up the WAF. And so the one thing that there needs to be a lot more collaboration across groups so that they can understand all the tools that are in the toolkit, because making use of WAF, what it does is it gives the developers runway so that they can mitigate the issue at hand. Because what you don't want to have happen is the developers going into a state of panic and releasing patches for the sake of panic, for the sake of the vulnerability and trying to mitigate the issue. Because if they don't have enough time, chances are they may introduce more defects, or they make vulnerability even worse, or even worse, introduce new vulnerabilities. So taking stock of what capabilities are available in your organization, I think is a fundamental thing, so that when a vulnerability does happen, you understand what mitigations are available to you.
Great. Eric, it sounds like Neezam is talking about not patching just for the sake of patching, but patching intelligently. Any other takeaways that we should be bringing in to this Log4j debacle?
I mean, I think the panel's really done a really good job of addressing it, but there's a couple of areas I know that we've talked about with some of our clients in the past, and it's come up often, is security isn't just in the code and the infrastructure that you've deployed. Security is also in the libraries that you use in your platform. So making sure that libraries are included, are well supported, well patched, and have a security lifecycle of their own can be an important piece to the security lifecycle of your application, because as we see here, there were tens or thousands of applications impacted by this issue. Not many of them had actual vulnerable code themselves. They just used a supported API from a supported plugin, essentially, and that really exposed them to some risk. So that risk is maybe significant and something you have to address in the libraries of the code as well. So we see some things like static analysis tools able to reach into libraries when they're included and do some checking of those, but you can't get to every one. So as our panel's already said, having the ability to mitigate those threats while the developers are patching with something like a WAF or otherwise is a great tool set. Great,
thanks. And I got one further question I wanted to throw out at Greg that just popped up. Greg, with software developers becoming an extended part of the security team, there was typically that segregation between what training or what preparation do they need to actually perform the role, and how would you go about delivering such training?
Yeah, it was tough. The way we started is we just got a guy. And then we actually started creating our own little framework, and we started asking like a 50-point kind of questionnaires, and we started to kind of is the data encrypted, and some of the very basic questions, are you using certificates, whatever, because we were dealing with, let's say, 50 some odd applications holistically. So what we were doing is just, trying to create this homegrown kind of infrastructure or this methodology. So then we learned that there's better frameworks out there to ask better questions. But we integrated the cybersecurity professional into the team so that they could also teach the other cybersecurity professionals and tell them something they didn't already know. But it was the key point was really them being able to talk and get them to talk the same language with the developers. Because we had tried this a couple of years previously, and it just failed miserably. They would just say, we need this and we need that. We didn't know what we were talking about. So it's really telling them, the developers, and motivating the developers and educating them. We do cybersecurity training. It's basic, but it does go through. We use like Noble 4 and those types of training. They've got lots of little training methodologies in there to teach them the basics. But it's really learning by doing. And again, telling people things they don't already know. Did you know that this code? Now, we now have like sample code repositories of like how to perform certain functions that we now have these code libraries. It's that's how we went about it. Now we're significantly more mature, but it took a long way to change the mindset of our developers.
So Eric, same question. There really has been a division in the past between software developers and the security team. The security team was typically left to their own devices, and now they're becoming an integral part of all the other teams within the IT organization. What training do they need to perform their role? How would you go about pushing that forward?
I mean, that's a great question. One of the things we're seeing right now is bringing a developer into the fold as part of the application or the security team, realistically, application security is a complex enough topic that it's difficult to say, give a week or two of training and be a real expert on it. You can get the basics. It's good to do that anyway. And I encourage cybersecurity is always an evolving field and something that needs constant training and keeping up to date with the current trends. But application development, application security are pretty complex topics. So one of the things we've seen and worked with organizations to help do is really bring an application developer up to speed on security rather than trying to go the other way around in every case. I think there's a way to meet in the middle there, but having part of your development team a dedicated security resource, or having an application security expert who's able to advise or work specifically with the application teams is important, because somebody you hired a few years ago who is a firewall expert but hasn't done any development in their past can learn the basics, but will struggle to get deep into the infrastructure, into the mindset of a developer and understanding all of the caveats and challenges that they're facing.
Eric, the only thing I'd add to what you're saying is, from a motivation perspective, developers actually can increase their wage and their knowledge and their potential to move if they're educated in cyber. Like I think they increase their value by 10 to 15 to 20% basically overnight if they can intangibly articulate that they have cyber knowledge and capability.
100%.
Great. Thanks for that, Greg. Gentlemen, I've come to the end of my questions. Barry, how are things looking on the chat?
Absolutely, and thank you very much, Tom, for the question. There are two aspects in every application development process. There is the technical aspect in terms of the software development, understanding how the applications work under the hood. And there is a business process, understanding how the application is used, the processes around the stories around how users or business people will utilize the applications. And those are equally important. And this is the first thing that you want to communicate to the rest of the IT team. You really need to understand both, to understand what's important to enable the application. Now, in terms of technical things, and we're talking about things such as Docker, for example, I think infrastructure as code that is becoming a trend over the last few years is a key to that, because we're no longer looking to deploy things and infrastructure configuration by hand. And we're looking more towards an orderly orchestration of things and orderly the provision of things when they're not needed. It started mostly with cloud, but a lot of teams are doing it on-prem. I think encouraging both security and infrastructure team to look into infrastructure as code and learn that would be fundamental for people understanding what software development teams are going through. So it's a good exercise, and I would advise companies to invest into training your infrastructure team, training your network team, training your cybersecurity team in starting with infrastructure as code, even if you're not consuming a cloud, even if everything is on-prem.
I was going to say, I don't think anybody's going to disagree that training is top of mind and top of the food chain for getting things done. Neezam, you had something to add.
Yeah, so it's interesting that Docker and containers has come up. And up until now, containers, Kubernetes has been focused on as being a development paradigm. What I'm starting to see with customers is that vendors are starting to pivot, and they're now releasing products as containers. So those infrastructure teams that have been working in the existing model, they're going to be forced into going into the Kubernetes and container frameworks. They're going to have to learn how to consume and use them. I see it, there's going to be symmetry between the way infrastructure works and developers work, because Kubernetes and containers, there's not going to be an infrastructure version of Kubernetes containers. It's going to be Kubernetes containers, and everybody's going to have to learn how to consume it one and the same. So I think over time, what's going to happen is that the infrastructure teams, even the cybersecurity teams, they're going to get indoctrinated in being able to use these components in the same way that the developers are using it.
Eric, I see you nodding. You agree with that?
I mean, yeah, there's a real shift in the industry, and I see questions coming in about cloud, and I see questions coming in about, a lot of the questions are about how is IT security getting up to speed on all of the new technologies, and this is a really real challenge for professionals. Almost aside from the business aspect and the management aspect is, in order to stay on top of the field, you can't just go through your day-to-day work. And I'm speaking directly to cybersecurity professionals here. You can't just go through and say, I'm a firewall expert, I manage a firewall, okay, now train me on the cloud. Frankly, that's not going to work very well. And really having a steady diet of what's new in the industry and new topics. Side projects and development are one of the ways I see in IT security infrastructure people. They go out and they build a sports betting website, like just for fun or for their friends. It really builds a mindset of, okay, this is what development means. This is what it means to get into this. That itself, that background, and I've written some code. I know how the code works. I know the pitfalls of running through test cycles. Is really what separates somebody who's good with application security versus an infrastructure guy who's learned what cross-site scripting means in a basic sense. There's a fundamental gap there in really having an understanding. So asking, the question about how do we train, how do we get to, get an infrastructure guy to understand app security, you can go to a course for a week and you can learn a lot, and I think that's valuable and important, but fundamentally shifting your mindset about how IT is and what you do, how you approach projects is kind of part of it. There's a real mindset difference between a developer and a network guy turned security person. So there's some challenges for the staff there, and really they have to address that and think, the world's shifting and I need to really understand this. So, cloud infrastructure and applications are the two fields we see like really becoming the future. And when we look at organizations, we see, the number of guys who have a CCNA who can manage a Cisco switch. It used to be one of the most valuable skills. A CCIE used to be the pinnacle of IT security, infrastructure certifications. Frankly, they're still useful. They're necessary. Obviously, all this stuff is not going away, but it's becoming less central to the IT infrastructure and core to the business.
Great. Thank you for that. Barry, have we got anything else in the channels?
I come from a mobility background, and so the difference between mobile apps and traditional applications is simply the way it's consumed. But I think the governance and compliance models that govern how applications can be consumed are still valid, right? Now you come into things like mobile phones might be in areas of the world where we don't want that app to function and whatnot, but that always comes back down to the governance and compliance. So, and even when we're talking about cloud, and when I talk to customers about this as well, it comes down to governance and compliance, because those rules really tell you how the business is supposed to conduct itself. Regardless if you're going to AWS, GCP, Azure, on-prem, wherever you may go, whatever products or services you consume, your governance and compliance policies are the fundamental pillar, that needs to be able to extend across all these different assets to ensure that you as a company are consuming them properly, you have the proper information stored across all the different assets. And this extends out to mobile applications as well. So if I was a security architect today and I was coming up with governance compliance policy, mobile applications would be an extension, but I don't see much of a uniqueness in terms of what a mobile application does versus a traditional application.
Can I take a stab at this one real quick? We see this in our app security practice here at Parabellyx. We do testing on both mobile and web apps. I think there's actually a little bit of a false dichotomy here, in the sense that it's almost a mistaken impression that web apps are monolithic, when the reality of modern web app frameworks is that there is a front end and a back end in most development scenarios. So you have a client-side code, you have JavaScript, and those things. Those are not reliably part of your security infrastructure. When you write code in JavaScript, when it's running in the browser context, when it's in the local object model in the browser, that's a place that should be considered insecure anyway. So essentially, you have an app. It's just JavaScript and Chrome. So when you do app like mobile app security, it's kind of the same thing. You have an app and you have a backend, and those are two separate things. So realistically, there is some difference in the skill set of understanding an Android app or an iOS app and the code that's running on them. But the actual security models there really should be similar, where we have the front end. The front end is JavaScript and HTML and Chrome and its engine on the website versus, say, Android and iOS with their mobile clients on the other side. Those are really kind of the same thing. Your fundamental gateway is your API infrastructure. Most modern apps are running an API infrastructure. Obviously, there's the old, classic web apps where that sort of API infrastructure is hidden in the code itself, and so that's a little different. But fundamentally, the security model is still kind of the same. So I wouldn't say it's too much different there. One of the crutches that you see in both cases is developers accidentally using or trying to trust that endpoint too much, putting business logic in the endpoint, whether that's a mobile app or in the JavaScript or client on the web, and using it for data storage without solid encryption. Some of those things are the pitfalls that we see, but they're both present in both sides. So I really don't think the actual security model changes too much.
Barry, I think we've got time for one more.
Well, it's also a very interesting and important question, because in many cases, when incident response team deals with infrastructure, they're more or less familiar with lay of the land. When incident response team starts dealing with application, depending on the team and depending on their level of involvement in other things, they may not be 100% familiar. So they're still great dealing with the underlying infrastructure components. However, they also need to understand the impact in terms of the entire ecosystem of the application, understanding where data is. And this is where a lot of time the discovery process that this incident response team needs to have is much longer for applications than if we're talking about traditional endpoints or infrastructure components. And again, the question is, how do you make this data available to your incident response team to cut down the response time, the initial understanding of the landscape when dealing with application-related breaches? And there are two ways of approaching. Obviously, making sure that you have specialists available, making sure that you have testing exercises, but also making sure that whatever is your incident response team, whether it's internal or external, have the information at their fingertips through your process, such as your incident response procedures, such as your playbooks.
So, folks, it looks like we might be coming up to our time. I know we've got a few more questions left in chat, but we'll have to, address those directly with the askers. But for the panel, one more question, if I may, and we're going to open up to the whole panel now. In just a few words, application security for 2022. Are there any immediate lessons you think development teams need to learn, or any major trends in the industry that we haven't discussed that should be top of mind for CISOs and application teams? Eric, I'm going to start with you.
Well, I mean, it's funny. The trend, like we said to start the panel here, is a continued shift away from infrastructure. And again, infrastructure is still important. It's still valid. It's still going to remain. But especially as we see in the pandemic era, work from home, we see a shift of away from data centers. I'm actually starting to see offices when we talk to customers who are looking to do security testing or architecture discussions. I say, what do you have on site? And they say, I don't know, some Wi-Fi, I guess. That's it. Right? Maybe a small firewall. That's it. It's all there is on site in some companies. Now, that's not universally true, but they've moved their compute to the cloud. A lot of their applications are in containers. They've got their apps serving all the data to customers. That's a major shift in the industry. It's a major shift in the mindset for security. So I think that's, I'm going to continue to beat on that, because that's how, that's what we talk about on a daily basis here is that's the shift we're seeing. A lot of people have their infrastructure pretty well understood. They know how to secure their firewalls. They're doing a pretty good job with hardening their workstations with it that they have. So moving that direction is I think continuing and will continue.
Greg, briefly, same question. Any trends or any immediate lessons that we need to take away from this?
I would just close on, there's a quote I'm going to bastardize from Obama, but it talks about having a moment where you understand or you tell something to a developer they don't already know. And what that ultimately does is it creates momentum in your program. And that momentum creates a movement, right? So unless you actually have the moments and you have those aha, situations, you can't build a culture, right? You got to tell developers and people something they don't already know. Otherwise, they're not going to buy into what you're doing. So I would say the trend that I see is you got to change your culture, right? Because if you change your culture, then that's where you're going to start to see all the interesting nuances of your ecosystem, because people are just going to start asking inquisitive, IT curious related questions.
Great, and I appreciate that. Neezam?
Yeah. So one thing I'm starting to see is refactoring of applications. So taking traditional applications and modernizing them. And I think that refactoring is an ominous term, because everybody thinks you just containerize your application, but it's how do you leverage the modern paradigms of agile development, functions as a service, multi-cloud, all these other things, and be able to realize an application that takes advantage of functions as a service, containers, Kubernetes, and all these different paradigms that now exist. And I'm seeing that this is more complicated than it looks. So I think organizations are going to be taking a real look at how refactoring actually looks, and really what is the effort that's going to be involved in getting there.
Perfect, thank you. Alex, I'm going to throw it over to you for the final word on this. Any trends or any lessons that we should be taking away and or should be watching for?
I want to build a bit on what Greg just said in his closing comments. And I want to say that the main trend that I see is application security teams realize they cannot do it alone. And the trend that will continue over the next few years is empowering the software development team, the application team itself, to become an extension of the security team and providing them with the tools that they can operate themselves under guidance of the application security team. And this is something that we've seen coming out both from the tool perspective and from the process perspective over the last year. But we're still very early on in the adoption. And this is something that will need to happen. That empowerment absolutely needs to happen for us to win the application security race.
And that's a great place to end it. Alex, thank you very much for that. I really appreciate it. Folks, I just want to let you know that this webinar is being recorded, and we will have that recording available for you. Greg, Neezam, Alex, Eric, I really appreciate your time. Thank you very much. Appreciate your participation and professional insight. And to the attendees, I'd be remiss if I didn't add, if you found the content useful and you're interested in seeing how building application security testing into your development pipeline would benefit your organization, I encourage you to reach out to myself or my team, or visit our website at www.parabellyx.com. Gentlemen, thank you very much for your time this afternoon. And folks, I hope you found some value today, and would like you to thank you very much for joining this discussion. Take care and have yourself a great afternoon.